So, lovely to meet you all. Thank you very much for the invitation to speak. It's a pleasure to be here. If I look a little bit ragged, it's because I had the overnight flight from DC last night. So if I go a little bit doolally at any point, please forgive me. This is about how cloud enables genomics at scale. And we're very pleased to be able to support some of the largest genomic programs around the world. And I'll go into a little bit about why cloud is being used to do this. By way of background also, I'm an academic interventional radiologist, and I'm still a faculty member at University College London. So I won't go into the why genomics is a good idea. I think we're all pretty much signed up to that. Likewise, the great talks this morning about the decreasing costs of the human genome and the amount of sequencing that's all going on around the world is known to us all. What you probably don't know is about what AWS is. So Amazon Web Services is the technology arm of Amazon. So it actually was built out of Amazon.com back in the day when they're building out websites and they're building out technology around the world. And they realized there was actually a massive amount of scalability here for other users of the technology to build out. So over the last decade or more, we've been building out technology infrastructure which others can leverage. And that really is the genesis of AWS. And we now provide services to national governments, state governments, research organizations, diagnostic networks around the world. And we have a team. So over the last 5 years, we've been building out the expertise within the team, specifically in healthcare. So we now have bioinformaticists, chief medical officers, technology officers from clinical organizations around the world that actually joined the team to build out this platform with a very specific healthcare and life sciences lens. And our mission is to enable, I think that's the key, it's to enable access and delivery of person-centered care to improve outcomes at a lower cost by accelerating the digitization and utilization of healthcare data. But as I say, the key is to enable. So we don't want to be a bioinformatics platform, we don't want to be a electronic medical record system, but we do want to provide the best infrastructure on which all of these things we platformed in the future, which will be interoperable and will allow scale. And so why healthcare in the cloud? Why are we getting involved? What should be your interest? Well, there are a number of different aspects of cloud computing which you should be aware of. So the first is security. And so managing data centers is not a sport for the faint-hearted. So if you are a clinical organization, or if you're a bioinformatics group, or if you're a clinical research organization, managing data centers is difficult, especially when the amount of data you're trying to manage is growing exponentially. And the security risks around that, keeping everything patched, buying enough infrastructure for knowing 5 years in advance how much you've got to have, is really difficult. Cloud enables traceability. It's really clear about who's accessed what and when. You can put really clear access controls in. Penetration risk can be decreased. Availability and durability. So again, with scale comes the ability to really architect things properly so your systems stay on. As a doctor, I want to know that when I use a system, it works. That's pretty key. And so again, we know that we can architect things to be available at the point of need. That's absolutely critical. And durability means that you don't lose data in the system. And so things are architected to be 5 nines of availability. So things stay on 99.999% of the time. Elasticity, you can scale up and scale down. You don't know what your requirements are going to be. If you want to run a big genomics workload, you're going to require thousands of CPU hours pretty much instantaneously. So we support 19 of the top 20 global life sciences organizations. And they run massive compute workloads, which they are able to turn on and then turn off again. And so that elasticity of requirements you can tap into. And democratization is the key. I think that is the real takeaway. So you don't need to have massive on-prem infrastructure. Previously, this is you can do this if you're in a lighthouse, ivory tower, if you have access to high-performance compute that's always available, because even then that's challenging. How you can access this if you're a researcher in a lower middle-income country? How can you access it if you don't have a 5-month lead time to buy the right number of GPU instances that make it available? The cloud enables you to access data, computing power, and networking on demand. And then we come to agility. And so what I mean by agility is the ability to build quickly. Because the other aspect of cloud computing is not just, you don't view it as kind of bare metal in the sky. You previously compute on-prem, and now I'm just going to compute on, program on someone else's computer. The cloud actually offers microservices. And these are little elements of managed compute and storage and services which do little things by themselves, and you can scale them. And so you can have compute instances which can scale up automatically, and they can scale around the world automatically. And so you don't need to code for them yourself. You can take this essentially off the shelf and build it into your new applications of the future. And so if you're a builder, if you're an applications builder, it actually decreases the time to build by about 50%, because you can take these microservices and build them out. And what we're doing is we're actually building out specific services for specific data types. So we've actually just launched AWS Health Omics, which is actually a service which can ingest omic data. It can store it in the most appropriate storage tier to make it the cheapest possible. So we're estimating it'll save about 40% on storage costs. And then it can stream to genomics endpoints. Likewise, we're building out services to manage DICOM data for imaging and text data, FHIR data for electronic medical records. So these aren't solutions. These are little elements that manage that data type, which will be built into solutions of the future. And so we launched AWS for Health in 2021, and you can have a look at that. So we already underpin a lot of the organizations you already know. So we've got great partnership with Oxford Nanopore, we work with Illumina, so that organizations which build genomic solutions are already platformed on AWS. And we're already supporting global biobanks. So again, you're probably not aware of this, because we want to sit one layer back. We don't want to be front of house. But you do need to understand that this is the technology and backbone which is linking all of these things together. And so we've got population sequencing initiatives running on AWS today in production around the world. And you can see all of these programs are running on AWS today. And so just to call out three of those, we've got a great program running with Genomics England, who presented this morning. They are hosted on AWS through a partner called LifeBit. They're the trusted research environment, which is built on AWS. We're also partnering with them around AI and machine learning, because again, AI and machine learning takes an enormous amount of computing power. And so to tap into that, they need to be able to build using AWS services. And so we've got a research partnership with them. We were actually presenting with them 2 weeks ago at the Genomics England Research Summit about the multimodal research we're doing around breast cancer, saying how we can bring in pathology imaging, genomic data and phenotypic data together to get greater insights about patients who are at the risk of breast cancer. Likewise, UK Biobank is platformed on AWS. We're using a partner, DNA Nexus. So they currently have around 15 petabytes of data hosted on AWS, and it's going to be around 40 petabytes of data by 2025. And someone says, 40 petabytes of data, is that big? I've got no idea. What does that look like? Oh, sounds really impressive. So just to put it into scale, 40 petabytes of data. If you like watching 4K high-definition video, you can watch 4K high-definition video 24 hours a day, 7 days a week for a century. That's what 40 petabytes of data looks like. So if you want to have scale, you can use this kind of platform to get that kind of scale. And we're seeing exponential volumes of data built out on this platform. And likewise, the University of Chicago is building out their Gen 3 platform. Had a fascinating conversation at lunchtime talking about standards and taxonomy and how we can all build to the same taxonomy so we can make those data sets interoperable. So Robert Grossman out of University of Chicago has built out the Gen 3 platform on AWS. They've got 17 17 petabytes of data, 15 different genomics data sets that span US, Australia, New Zealand, South Africa, which are interoperable, and they are federated. And I think that's the way of the future. I think if we can go to more of that federated data sets, I think we'll just get greater power behind all the research that's taking place. So we've got several programs and initiatives you should be aware of. We've got the Registry of Open Data on AWS, so actually allowing access, so it's free access to these data sets. We host them for free, and they can be accessed by researchers. It's the largest kind of cohort of different data sets around the world that you can access via AWS. There's the Cloud Credit for Research program. So if you're a researcher building out or doing research on AWS, you can apply for cloud computing credits to provide free research. And also we have a health equity initiative. So we've got $40 million over 3 years, which are being made available for programs which address issues of health equity. And so far we've given away $14 million of that to 90 programs around the world. And finally, there's an issue of sustainability. And so sustainability is key as well, because if you're running massive data centers and computing power, it takes a lot of fuel to run. And so by running on the cloud, you can offset your carbon emissions. And so we know that running on the cloud, compared to the median US data center, is 3.7 times more efficient. Compared to the median European data center, is 5 times more efficient. And so it actually has an 88% lower carbon footprint. So as you're considering your data sets in the future and the massive amounts of computing that you're going to require, think about your carbon footprint, because ESG is getting higher and higher on people's agendas. So takeaways: democratization of access is absolutely critical. Coding on the cloud is different to building on bare metal. You can build faster. We already support national programs, and sustainability in the future will be a real feature. And the question is, how can we help you? We're here to help. Thank you very much.